Word problem number 7 is a classic related rate style problem. This is perfect for differentiation review. I'm excited. So it tells us about a paper cup, but it's in the shape of a cone, so I'm going to expect that it's like this. And it says it has a height of 10 centimeters and a radius of 3 centimeters. So I'm sure we can agree on that. I'll put that 3 over here somewhere like that. Hope you can see it. It's a little small. If water is poured into the cup at a rate of 2 cubic centimeters per second, so that's a change in volume and a change in time. And I know that for sure because it's centimeters cubic, which is volume, per second, which is time. How fast is the water level rising when the water is 5 centimeters deep? So they're asking us for a change in height for a change in time. This is what they want. And they tell us that the current height is 5, so the water is here somewhere. We'll say h equals 5. We'll draw some water in there. Okay, here's our paper cup. Normally in 3rd grade you just drink out of the paper cup, but we have to calculate just how fast it's rising. So where do we begin? Well, I think the first thing we want to do is write the volume of a cone, which is 1/3 pi r squared h. Now I remember that because pi r squared is our circular base, and then the height, and then 1/3 because it's slanty. I know, it's pretty technical. And this particular cone has a radius to height ratio of 3 to 10. And the reason we need to understand that is we have two things changing here. We have a radius and a height. And if you add water, both of those change. But when we take a derivative, we want things just kind of in terms of one thing. So I think what we're going to do, since they're asking for dH dt, is we're going to put everything in terms of h. So let's multiply h up and the 10 up and divide the 3 down. And I think what I get is that h equals 10r over 3, or the other way around, r equals 3h over 10. I can never remember which one I want to use, so that's both of them. Will come in handy here. If I want in terms of h, then I need to replace r, so we'll use this guy, and I'll rewrite this as 1/3 pi times 9h squared over 100 h. And 9/3 is 3, so that would be 3/100ths pi h cubed. This is our volume for this particular cone. And we have things in just in terms of h now. So we can take a derivative. dv dt equals, let's bring the exponent down. That'd be 9/100ths pi h squared. That feels good. Now don't forget, because we're taking a derivative with respect to time, you need to chain rule dH dt out of here. And wouldn't you know that's what they're asking for? So that means that we should know or be able to figure out this and all of these. My dV dt is given to us. It's 2 cubic centimeters per second, so we'll say 2 equals 9/100 pi. Our height is currently 5, so that's times 25. dH dt. Okay, we're getting warmer. We are getting warmer. Let's multiply the 100 up. So we get 200 equals, that would be 225 pi dH dt. So dH dt is going to equal 200 over 225 pi. What's that going to work out to? I think I have a pi button here. I do. It's going to work out to 0.283. Now the question is, what is the unit? It's a change in height. They give us a length. It's centimeters per second. And that's the answer. So these related rates problems are all about making not the mistake of leaving the chain rule out, But more importantly, when you have these multi-variable problems, you have to separate and identify a way to keep it all in terms of h or all in terms of r, whatever we're trying to solve. In this case, we want to know height. So we got rid of the r by replacing it with the specific information for this particular problem from the general form. So you take the general formula, you add in the specific information, and then you take a derivative based on whatever they ask. They asked for a change in height per second. We gave them a change in height per second. Awesome related rate stuff.